Hello. In this video, I will show you how to model variable speed limit signs or variable speed limit. This is just one option to do or one way to do. You can achieve it with other tools as well, of course. In this example, I will use attribute modifications. Variable speed limits are used in many countries to improve safety, to reduce shock waves, or to just to impact or to remove or to improve the traffic flow conditions. And there are, of course, other use cases as well. We use detectors in this example to understand the condition, the traffic flow conditions. We are going to use the same port number for each detector. 1. We use desired speed decisions in each lane to update the speed limits, and we use attribute modifications to convert that information from the detector to inform the speed change. Okay, let's have a look. So the object we target is desired speed decisions. The attribute we target is the desired speed distribution for cars. We will use a different attribute decision or modification, sorry, to copy that data to the others as well. If you have multiple vehicle types in your model or classes, I'm not using any object filter because I want to update all speed decision in the model. But you can add here something if in your model you have multiple locations. The formula. Okay, so in the previous video for attribute modifications, I showed you what table lookup is for. Just a quick lookup, just a quick catch up on it. With table lookup, you can access other objects in the attribute modification other than the object type you use here. I want detector data, so I need to use table lookup detectors. I'm going to call that my variable. It could be anything I want. Then within that, I have port number 1. So this segment of the table lookup, this one, that one, is the second segment, and that is the condition. That is where you need to add your condition. So what I want it, the table lookup, to get data for all detectors where the port number is 1. Then the third one is the output or the result. This table lookup results in this. So it will give me the occupancy rate of detectors. So if you go to detectors, there is an occupancy rate there. So if you don't see it on the left, you just need to place it there. You see the attribute name is occup rate, time fraction, how long the detector is occupied during the past simulation second. And it is exponentially smoothed for each simulation second. We will come back to that, this smoothing. Okay, so the output is this, the occupancy rate for the detector. And since all 4 detectors use port number 1, there will be 1 occupancy rate for all 4 detectors. Then, if you see, the bracket is closing there. So, if this table lookup, the output of it, the occupancy rate, is about 0.8, because occupancy rate, don't mix it with occupancy. Occupancy rate is between 0 and 1. It is a percentage at a proportion. So if it is very busy, that means there is queuing, very slow moving traffic, shockwave, something like that. Then, because there is an if, and for if, this is the condition. If that's true, this will happen, 40. If it is not true, then this will happen. So basically we embedded if in if in if. So we compound ifs. We add a new if here. So if I add an if function, it's a condition outputs W if B is true, outputs F is B if B is false. So condition true, false, like in Excel, similarly. Then if it is not above 80%, then it will undertake this one. What does this say? So here I have two sections or segments merged here with an AND operand or operator. So table lookup detector the same as above 50% and below 80% or equal. So the traffic condition is better a bit. It is not very good, but it's better. So the speed is a bit higher, I allow. So I allow a bit higher speed here. And this is again a new if. So from here, going up to there, is the if condition. And if that is true, then the result is 50. If that is not true, there is another if again. Here, if the table lookup, so basically what I say, if the occupancy rate is below 50%, then it is 60 the speed. This 60 is just a final false output. So if none of this is true, then it's 60. Of course, there is no such way because either bigger than 80% or below 50 or between the two. But you need to input something here. And then you just close the brackets, all the brackets. Because you open multiple ones, you need to close them. I know it is a bit, it can be complicated. That's why I try to indent it a bit and to put into new rows. So as you can see, you can put them into new rows. You can cut it. You can wrap the text. And indentation is not necessary. So you can just leave this out if you don't, if you want to, or you can put more. It is not Python, so it doesn't matter. It just helps to understand, hopefully. So let's OK it. The second attribute modification is just basically I target the HGV, the heavy vehicle speed distribution, and I make it equal. Basically, the new attribute value is calculated as the car. So whatever speed limit I have for cars, it is now copied into heavy vehicles. If you have multiple vehicle classes, you can just repeat the same. Just having here the different like bus, tram or bike or whatever. Of course, you don't want to put 60 speed limit on a bike, but who knows? Okay. And now if you run the model, or if I run the model, I show the percentages. You can see it is increasing. And if you wait a second, let me just speed it up a bit. So it will soon. So it is 50, just the label is not updated. Let me just go back here to show you the. So it is 70. If it's gonna reach 80, then it will drop to below 40. 76. So now let me just do that change so we can see the changes. So do you remember we talked about smoothing, and in the video I made before for smoothing factors I didn't really talk about it because it wasn't important. But for occupancy rate there is an equation Vissim uses to calculate the occupancy rate, and with this smoothing factor the default is a quarter only, like that, for increase and for decrease. If I increase this smoothing factor, or if I keep it as default, look how quickly it changes. You see it runs up, then it goes back, it goes up, it goes back. So it's not really suitable. But now you can see the change, 40, 50, 60, 50, 40, 60. So it's not really useful. So the smaller value you use as a smoothing factor, the slower the change will be. So maybe if you use 0.1 only, then the change will be longer, so it will be more like an average. As you saw before, it was moving between 60 and 70%. So I think a quite small number is more suitable for this application. But of course you can use headway or any kinds of other metric and process that here and not occupancy rate. That is your choice. Um, but in this case, that is what occupancy rate is for. There is one other consideration. So in real life, they don't change these speed limits in every second. So if you see here in the period, I put 60. So this means it changes every minute. But if you want to change it every 5 minutes, you can just put 60 times 50, or you can just, sorry. So instead of 1 minute, you can have 2 minutes, or 4 minutes, or 5 minutes, or so on and so on. So with that one, you can calculate the frequency of the change. So I think this makes a brilliantly simple tool. And if you want to make more steps here, you just basically copy this here and just add another bracket and just update these little proportion figures or these percentages, and there you have it. I think it's brilliantly simple. Um, I hope it was helpful. If you like what you see, please consider liking and subscribing. Or if you want to support the channel, you can do that if you join my Patreon page and you can pledge your support. Thanks a lot for watching.